charged my phone yesterday. It is running out of battery.
Next time you should buy a solar panel charger. Like something like this.
What is this?
Well, it has solar cells inside that convert the light energy to electrical energy.
Wow, that sounds cool. But how does it work?
A solar cell is otherwise known as a photovoltaic cell. Photo for light, voltaic for relating to electric current produced by chemical action. Now, before I explain further on what is a solar cell, I will the molecular orbital theory. Molecular orbital theory helps to draw a parallel between molecules and atoms by describing the molecule in terms of orbitals, orbital diagrams, and electron configurations. This MO theory assumes that the molecular orbitals are viewed in a way similar to atomic orbitals. The MOs are viewed such that the molecule is in its lowest potential energy state. Secondly, we follow the Pauli's exclusion principle, which is the maximum number of electrons in an orbital is 2. Then, following times rule, orbitals of equal energy are filled with parallel spin before the electrons pair up. We see that there is one molecular orbital that is lower in energy. This lower energy molecular orbital has a greater electron density between the two nuclei. It is of lower energy than the two 1s atomic orbitals of the hydrogen atoms, making this atom orbital more stable than two separated hydrogen atomic orbitals. There's also another molecular orbital which is at a higher energy state. This higher energy molecular orbital has a lower electron density between the two positively charged nuclei. The energy of this orbital is greater than that of two of the 1s atomic orbital, and such an orbital is called an anti-bonding molecular orbital. Is it anti or anti?
Anti.
It is denoted by an asterisk in superscript. In general, a molecule has to have a bond order of more than 0 to exist in a stable form. To illustrate how a solar cell works, we need to understand what is a HOMO, a LUMO, and what is band gap energy. HOMO stands for highest occupied molecular orbital, while LUMO stands for the lowest unoccupied molecular orbital. Simply put, the HOMO is the highest energy molecular orbital with at least n electron, while the LUMO is the lowest energy molecular orbital with no electrons. The band gap energy can be explained as the difference in energy between the HOMO and the LUMO. The lower the band gap energy, the more easily a molecule can be excited. Semiconductors, like every other compound, have molecular orbitals. In silicon, there is a small band gap between the HOMO and the LUMO. Introducing the N dopants will allow the HOMO to be at higher energies, while introducing the P dopants will allow the LUMO to be at lower energies, further reducing the band gap. This reduced band gap allows efficient conversion of the sun's rays to electricity. When enough energy, supplied through photons, is supplied to the doped silicon, the pool of electrons is able to jump the band gap from the HOMO to the LUMO. By doing so, the electron is no longer bound to the atom and is mobile. These delocalized electrons act as charge carriers and can then carry electrical charges. The continual flow of electrons allow the silicon to generate electricity.
Start.
Wow! So the solar cell is really useful to us. But my handphone is still out of battery.
Okay, I'm so sorry. Now, let me my hand. The end.